and y-intercepts again today. Obviously we looked at it yesterday, but I think we can do with going over it again. So, an intercept is a point at which something crosses. Later on this week, we're going to look at point of intersection of two lines. This, though, is where a line crosses an axis. So the X-intercept is the point at which the line crosses the x-axis, and the y-intercept is the point at which the line crosses the y-axis. The kind of counterintuitive thing, though, really, is that when it crosses the x-axis, the y-coordinate is 0. And when it crosses the y-axis, the x-coordinate is 0. So that's what the coordinates would look like. Okay? We don't know what the x-coordinate is there, and we don't know what the y-coordinate is there. But the others are 0. So you're all happy with that, are you? Okay. So let's have a look at it then. So we have a function. So let's look at this function. Y equals 3x take 3. So we need to find the x-intercept, so where that line would cross the x-axis, and also the y-intercept. So the x-intercept is when y is 0, that's the slightly more complicated one. And the y-intercept is where x is 0. So if you remember when we looked at our table of values, and we had our x and y values there, and that was 0, 1, 2, 3, 4. This number here relates to our function, doesn't it? And so we can actually find the y-intercept pretty quickly. So which part of the function here relates to the y-intercept coordinate?
The constant.
Yeah, the constant, the -3. That's right. So the y-intercept is going to be what? 0, -3. That's right. 0, -3. Okay. So if we were to have our Cartesian plane, 0 across -3 down, that's where the line would cross the y-axis. Okay, so the y-intercept. Now, can anyone remember how we find the x-intercept? This is a little bit more complicated, isn't it? Not very much more complicated, and often, remember, it ends up as a fraction. But how do we do it?
Do an equation.
We use an equation, so we use algebra. So what value do I need to insert into that equation to help us solve it?
0.
Yeah, that y is 0, that's right. So let's substitute the value for y as 0 into the equation, and then y is going to equal 3x take 3. So 0, because that's our value for y, because we need the value for y, don't we, as 0, is going to equal 3x take 3. Now, how am I going to solve that one? What do we do next?
3 take 3 from both sides.
Take 3 from both sides.
Add 3 sides.
Yes. So we need to get rid of the constant, don't we, here? And so we do the inverse. So we add 3 to both sides. So 3 equals 3x. Now what do I need to do? Yeah, divide both sides by 3. So 1 equals x. So in the x-intercept, where y equals 0, our x-coordinate is 1. Okay? So it's 1 across 0 up. So that would be about there. Okay? So that's 1, 0. So now we can actually join those 2 points together with a line. Don't forget your arrows on both ends. And the function of that line is y equals 3x take 3. So the other thing, if you are given both the intercepts, you can actually graph the line and work out the function for the line as well. You can do it backwards. So let's do another one like this. So we'll have a negative one this time. So we'll have y equals negative 5x plus 3. Try and have one that ends sort of as a fraction. So we need to do our y-intercept. It's the easier one. And then our x-intercept. So, what do we know about the y-intercept? Which coordinate do we know already? It's going to be 0 because the x value has to be 0, doesn't it? And then our y value is going to be positive 3 because it relates to the function. Everyone happy with that?
Yeah.
That's pretty straightforward. Okay, so our x-intercept, we've got to have the y value as 0, and we need to find out what the x coordinate is, don't we? If we do this one here, 0 across 3 up, that's where that one will be. Okay, so tell me what I need to do to the equation.
Substitute the y for 0.
Very good. So substitute the y for 0. So we'll have 0 equals negative 5x plus 3. Now, what do we do now? Because what do we want to get rid of? The negatives, don't we? So we could take away the constant, but then we'd have negative 3 equals negative 5x, and then we have to deal with those negatives. So let's get rid of the negatives if we can. So what are we going to do?
Add 5x.
Add 5x to both sides. Well done. So 5x is going to equal 3. Okay, because we've added 5x to there, which gives us 0, added 5x to there, gives us 5x. What do I need to do now to solve for x?
Divide both sides by 5.
Well done, divide both sides by 5. So x is going to equal 3 over 5, or 3/5, or actually 0.6 if it was a coordinate. So our coordinate here will be 3/5. Okay? So it's going to be 3/5 across, so just less than 1, and 0 up. Now, this line is going to go this way, isn't it?
Yeah.
It's got a negative gradient. How would you tell that just from the function? Excuse me. Bless you. Yeah.
Because the x-axis is negative.
Because the x value is negative, well done. Because the m is a negative. Good.